Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we will be learning a different type of transformation, which is rotations. So for the do now, we have the following problems. Find the reflection of triangle ABC over the origin, given that point A is 2, 2, point B is 2, 7, and point C is 5, 2. And then for the second part, what other transformation could you apply to triangle ABC to obtain triangle A prime, B prime, and C prime, which is basically the image of triangle ABC. So let's graph this first. So let's plot the points A, B, and C. So there you go, we have this triangle here, okay? With the respective points A, B, and C. Now, according to the do now, we want to reflect this over the origin to obtain this triangle here. That's the image. So we have A prime is -2, -2, B prime is -2, -7, and C prime is -5, -2. As you notice, when you reflect an object over the origin, you negate the x and y coordinate for each of the points. Now for the second part of the do now, it asks what other transformation could we apply here other than a reflection over the origin. Basically, how could we go from triangle ABC to triangle A prime, B prime, C prime using a different type of transformation? Well, we can definitely not use a translation here, but we can actually rotate the entire triangle over the origin in a counterclockwise manner in this way. Okay, so we can actually rotate it by 180 degrees. And that's basically the introduction to today's lesson of rotations. So when we talk about rotations, there are a few things that we need to define. First of all, what is the notation? What's the definition? But also, what are you rotating about? Which point and by how many degrees? So let's establish all of that. So here's the definition. A rotation is a transformation in which a figure is turned around a point called the point of rotation. And here's the example. So let's say you rotate that triangle over, and the triangle is in reality being rotated about a point of rotation. In this case, it's the origin itself, okay? So you can think of it as kind of like the radius, okay? So for example, if I draw it in like this, and then you end up at this point here, like that, okay? So you basically have this. So you are going to rotate the triangle this way, okay? And maybe we can establish also, okay, how many degrees is that? Which direction? But anyways, that's what it means about that point of rotation. So here's the notation for rotation. It's a capital R, okay? So now we have to be careful to use capital R because lowercase r is designated for reflections, okay? So the first point here, or the first subscript in this case, that is the point of rotation, okay? So for example, if you go back to the definition, it's called point of rotation. So let me write this in. That's the point of rotation. And this one is the angle measure in degrees, okay? So we will use degrees here. So something worth noting here is also the following, that if theta, let's say it's greater than 0 degrees, okay? So let's say it's a positive, let's say 30 degrees, then you're actually moving counterclockwise. And if angle theta is negative, so let's say, for example, -45 degrees, you're actually rotating the object or the points clockwise, okay? Again, counterclockwise means this way, and clockwise means this way. So we can put a positive here and a negative here. And I know it seems a little bit counterintuitive, but that is basically notation in mathematics and also in physics, often you can see that, okay? So in this case, you're actually rotating some point xy, and you end up with the image, which is x prime and y prime, okay? So maybe at this point we can ask ourselves, okay, so how do we even find x prime, y prime for the various angle measures, okay? And that's basically today's lesson. Like, for example, let's take a point xy, let's say 2, 5, and you rotate it by 90 degrees or 180 degrees or 270 degrees. What are the resulting coordinates of that pre-image? And that's what we're trying to discover in today's lesson, okay? So let's get started with the following example to come up with a standard formula for these. It says here, rewrite the coordinates from the do now in rotation notation. What general rule do you notice? Okay. So when you go back here to the do now, we have these points A, B, and C. Okay, so let's rewrite each point in rotation notation. And as you remember from the diagram here, that when we rotated it, we obtain the following points, okay? So let's rewrite this in rotation notation and see if we can come with a general form. So for the first point, we have this, right? So point A, we're rotating over the origin by 180 degrees. Again, it's positive because we're rotating counterclockwise, the point 2, 2 to obtain negative 2, 2. Now for point B, we did the same thing. Point 2, 7, rotating 180 degrees over the origin, we obtained negative 2, negative 7. And finally, for point C, we rotated the point 5, 2 by 180 degrees over the origin to obtain negative 5, negative 2. Now, do you notice a general rule here that we could write? Let's say you're rotating a point xy over the origin by 180 degrees. Then what are the resulting points? What is the image? It will always be negative x, negative y. And that's basically the general rule. So what if we have different angles now? For example, what if we rotate a point xy, again over the origin, by 90 degrees or 270 degrees or 360 degrees? What will be the image in this case? And that's something you can maybe think about. If you want, you can pause the video and think about what the images should be here. Okay, so let's try to figure out the first one, okay? This one, the rotation over the origin by 90 degrees. So the best way to figure this out is with an example, okay? So let's pick a point x, y, and let's make this to be 1 unit and this to be 1 unit on the x and y axis respectively. Let's just pick a point, for example, 2, 4, okay, over here. So this is 2, 3, and 4. Let me actually label all of these. So here we have 1, 2, and 3. Actually, let's pick 3, 4, okay? So this is the point P, 3, 4, okay? So how would you figure out what the resulting point will be, P prime, after rotation of 90 degrees? Maybe the best way to do it is through construction, okay? Okay, so here we constructed a radius here congruent to this one, right? And this is point P prime. And we moved counterclockwise, so this way, by 90 degrees, okay? So you can easily construct that actually on a graph paper and measure the distances with the compass. So if you do that and you measure the distances, for example, here now we have 1, 2, 3, and 4. So we have negative 4, and the y value is still 3, right? So let me rewrite this here. So here we have P prime to be negative 4, 3, okay? So it seems like that here we swap the x and y and negate the x value after we swap, okay? And that is basically the rule, okay? So if you rotate a point by 90 degrees over the origin, you negate the y and keep the x, but then you swap it. So if it's x, y, will become negative y, x, as you can see here, okay? So let's analyze the 270 degrees now. So again, for 270 degrees, you can construct a circle now starting at this point P and then moving counterclockwise all of this by an amount of 270 degrees, okay? If you construct it, you can also go clockwise by 90 degrees because again, 270 plus 90 is 360 degrees, okay? Now again, what you can do is count this. So here we have 4 for the X value and the Y value here. If you count the units, you end up with -3, okay? So there you go. We have also a general rule now for 270 degrees, okay? It seems like that it's going to be y comma -x, and that's basically it. Okay, so that's the rule. Now, let's look at the last one. So the last one is pretty obvious, right? If you go around 360 degrees, the image will be the same as the pre-image. So therefore, a rotation of the origin by 360 degrees of any point xy is equal to x comma y. So these are basically the general rules here, okay? Now, obviously, there could be some deviations from the rule. For example, what if you rotate an image or an object over a point other than the origin? What will happen in that case? That's something that we can also deal with in geometry. But something that will become a little bit more challenging is if you rotate a point by a degree measure, let's say by 30 degrees or by 57 degrees or some arbitrary angle, so any angle theta. Well, in that case, you would have to use trigonometry and more advanced mathematics that is not being covered in honors geometry here. So what if, let's say we have a rotation of a point xy by an amount of theta about a point other than the origin, let's say some arbitrary point AB. And how would you find the image of that point, the image x prime, y prime? Well, let's sketch it out. So let's look at this example here. Let's say I'm rotating this point P prime, and I picked an example here, for example, P prime to be 3, 4, which is the same point as we had previously, but now not over the origin, but we're rotating that point P prime over this point. So let me use a different marker. This point that I chose to be 2, 1, okay? Let's say we're rotating it by, I don't know, let's say 90 degrees, okay? So you do the same thing. So you would measure this distance, and then you would rotate it by 90 degrees as shown here. From point P, we end up at point P prime if we rotate counterclockwise by 90 degrees, okay? So if you think about this, that is actually also a transformation, okay? So if you, for example, go from the origin, right, to this point over here, so let me designate it this way. So you basically, what you can do is rotate point P over the origin and then transform it back, okay? So if you think about this, this is actually a compositions of transformation, okay? So let me write here what I'm trying to do here. For example, in this case, we have the rotation about 0.2, 1 of 3, 4, and that is the same as if you rotate the point over the origin, okay? So that means that first we need to translate the point to the origin. So we translate the point by an amount of -2, -1, okay? So we translate the point 3, 4, followed by a rotation over the origin by 90 degrees in this case, and then followed by a transformation again by 2, 1 to go back to the original point, okay? So we can actually do the math here and kind of verify this on the graph, okay? So let's say you transform this first. So here we obtain the point -1. Actually, we obtain the point of 1, 3, okay? So now we're going to rotate that point over the origin by 90 degrees. So let me write down the rest here, 2, 1. Okay, so again, if you rotate 1, 3 over the origin by 90 degrees, you negate the y and write x. So it's negative yx. So it will be negative 3 comma 1. So now we're going to transform the point back to 2 comma 1. So we're adding these, okay? So 2 plus negative 3 is negative 1, and 1 plus 1 is 2. And that is basically the result of rotating point 3 comma 4 over the point 2 comma 1, right? And we end up with this. So does that make sense? So let's go back to the graph and see if it's negative 1 comma 2. So here we have negative 1 and here we have 2. And as a matter of fact, it is negative 1 comma 2, okay? So here's a summary. If you rotate a point xy about a point other than the origin, okay? So basically, you read from right to left again like this, okay? First, you transform the point xy by negative a comma negative b, okay? That are defined by these values here. Then you reflect the point over the origin by an amount of theta. And then you transform it back to a comma b, okay? Okay, so that's basically it for today's lesson. I hope you enjoyed today's lesson. And if you have any questions, please post a comment in this YouTube video in the comment section. Click like and subscribe, and have a fantastic day.